And hi everyone.
Hi.
Welcome to a new week, week 8 in ESP. We have a completely new setup today. We won't have it too often anymore. Probably the first and last time. But we're here in person actually, both of us. I mean, you're always here in person. I'm not here in person usually, but I am back actually in Austria. Just arrived on Monday, and I'm very happy to be here today with David and do the lecture here.
Yeah, also very unexpected for me. Unusual, but hopefully we will do it like always the last few weeks. So I'm happy that you're back. Let's look what we want to do today.
Right.
So we will talk about file I/O. So until today we expected to have everything in our program all the time. The user input was just the only thing we can interact with our program. And today we want to talk about files. We want to read files and work with files in general with our program. And then I think the most interesting part of,
definitely
for me, the whole lecture of all weeks is we build our own data structures, and here we merge all our knowledge from the past few months.
Everything combined.
And that will be very cool. And our guest lecturer will then make a programming demo.
Yes, live programming. Usually people treat me always with a kind of a smile and say Alex is never doing some programming, and today I have a huge programming thing to show that I can also do some C programming.
Who said that?
Heard that. Rumors.
All right. So at first, in the beginning, as always, I think we should do a short recap of last week. We talked about enums. Enum is a cool way to combine things which are like a defines or constants. We had this example with weekdays where we have all the days of the week. And then we can use this writing style as it would be a data type. But then we said, okay, it would be cool if we do not need to write this enum weekdays. So we introduced the type def, and when you write type def and then an existing data type and a new data type you want to define here, then you can use it really like as an integer, a float, whatever. And that's a very cool thing to create your own data types.
Right.
Then we talked about structs. So structs is just a combination of things which may belong together. In this case, we had a person with a name with a maximum of 50 characters, should be sufficient for most of the names here. And every person has also a birth year, hopefully. So these are the members of the structs, and then we can create a person like this here, and then we can access the member of this person. And again, using type def is in this case also better, because when we write type def and then struct person, we define it as a new data type person. Then we can use just this name as data type, and it's much more convenient. We talked also about struct pointers a bit. We will talk about it today even more, I think.
Definitely.
Created here King Charles, a person, and then also it took the reference from this element in a pointer. We can access of a normal person, we can access the members with this dot. And when we want to access the member variables of a pointer, we need to dereference it first and then using this point to get to the member variable. But there's a shorter notation, a shorter writing style for this, and this is this arrow here. I think most of the time we will use this arrow because it's much more convenient to dereference it first and then access the member of a struct.
Martin just asked in the chat if there is a reason not to use type def. typedef is perfectly fine actually.
Yeah.
You have like the short version there for there might be some cases, especially when you have a struct within a struct where you have to write struct actually. We'll do that today. But besides that, you're perfectly fine with just a typedef struct actually.
Yeah. So
we had a problem here, right?
A short quiz for you. What might be the problem in this case?
Is this a new one, or do we had this last week as well?
It's a new one.
Wow.
Yeah, a little bit modified. Motivated by the problems we had
I see.
Last week. So, is there any guesses what can be the problem here? Have you seen it already? Do you know what's the problem?
Actually not.
I won't ask you, don't worry.
Yeah, I went through the slides, so.
Any guesses what might be the problem? So we are creating a struct here, again with the name and the birth year. Then we create here a person. Then we create a pointer to the person, to another person. And then we access here the birth year of Snape, and then we like dereference and access the member of the birth year member of Tom Riddle. So the error is not years, they are correct. I've checked it.
The pointer points do nothing.
Yeah, exactly. So this pointer is just a pointer, and it is not a struct object in this case. It's just a pointer. So when we dereference it like this, we will get the segmentation fault because we are dereferencing a pointer which do not point to a struct element. So we also can have a look at it in this scenario here. So again, we have here the Snape and also a pointer. And in this case, when we do size of Snape, we get 56 back. So the size of a struct is always the sum of its containing member sizes. So the name here is 50, so we have 50 bytes for that. An integer is 4 bytes, so we have 54. And in the background, the compiler does some optimizations and aligns it always to the next 8 bytes. So that's why we get 56 as a size of this struct. But when we look at the pointer here, the size of the pointer, it's just 8 bytes. As always, we have always said that a pointer is always 8 bytes. So they are not in the same size, and if we want to access the member variables of Tom Riddle, it's not possible because it's just a pointer and not an object. So in this case, if we have a pointer, we should, for example, go to the heap, allocate memory for that, and then we can use the memory for that.
So it's not sufficient just to cast to a person. Actually, since we have a pointer here, what we should do, as David mentioned, create an element on the heap, for example, or dereference one, and then you're fine.
Exactly, yeah. Another short quiz. What could be the output here? So we talked a little bit about this here. We had a mom and a dad pointer again. And what's the output here? So we print the size of a person in this case. What could be the output? This is what you also mentioned before. Here inside,
right,
you have to write this struct notation because the data type person is only defined starting here.
Yeah.
So inside is not defined. You need to write it like this. Okay, I have some answers there. The correct one is, so the first character array is 50 bytes. The integer is 4 bytes as usual, and we have additionally 2 pointers there. They are 8 bytes as always. So overall we have 72. I think when we calculated it's 34, 62, 70, and then 2 bytes to align it to the next 8 byte, which is then 72. So that's the correct output in this case. Right, that was our recap.
Good recap.
Yeah.
Short recap. we will use actually all what we did in the last week today.
Exactly. Are there any questions? Have you seen?
Nope,
Some in the
not
chat?
really.
Perfect. Yeah, then we can start with file I/O.
Actually, this is a cool topic because, as David said, in the past, opening a program, running a program closes, data is away. And what we're doing now with file I/O is we store some data persistently, and this is cool.
Yeah. So in general, you might have noticed it already. We're talking about, or we have been talking about streams. So there is one stream called standard input stream when we just type something into our program with the keyboard, and sometimes we've talked about standard input, and this is everything you really input into your program. Most of the time by the keyboard, for example, but you can use it otherwise, what we'll see now. And there are two other streams, the standard output streams. This is most of the time the case that the program prints to your display. So this is what you really see. And there is another second output stream, standard error. I don't think we used it.
No, we don't use it. We mentioned it if someone read the instructions for the KU quite carefully, because what we forbid is to use or to write something on a standard error.
Yeah.
But I think this is a legacy thing, since I don't know if the test runner is actually still using it. I'm not 100% sure.
know, yeah.
In the past, the problem we used the standard error to
Yeah.
report errors from the test runner
So
as well.
as the name says,
It's for
errors, yeah. And if you have an IDE, for example, sometimes there is in the output something marked red. This is most likely that it's from the standard error
Right.
stream, and then the IDE can interpret it
Yeah.
and mark it in another color,
Yeah.
for example.
It's good because then you can have the distinction. Output can be everything that went good in the program, and standard error is everything that went bad. Like
Yeah.
cannot read a file, cannot allocate memory. These things can be printed on the standard error.
But in our assignments, we do not allow it.
Right.
Yeah. All right. So these streams can be textual in a textual format or in a binary format. We will talk about textual format, but binary format is not that different. It's just another form of representation. The bad thing is that you cannot. It's hard to visualize or harder to visualize because there's not text. It's just binary, but it's not that different in representation.
And also in handling.
Yeah. Okay, so we often used scanf and printf, of course. And this is really just another representation of fscanf using the standard input and fprintf using standard output. So this is the same in this case. But we could also use, instead of standard input and standard output, for example, read from a file and write to a file. So we can write here with this fscanf. We do not want to have standard input, so the keyboard, so we want to read from a file. And the other way, we have fprintf, we want to write to a file and not to
The screen, for
to
example.
the screen. Yeah. And there are two types of file. Textual files, as I already said, they are easier to read, of course, because when we have a binary file, there's just nonsense in when we open it with a text editor. These are just the interpretation of these binary values, which do not really make sense in this case. But also, I think at the third assignment, we have text files.
Right.
Yeah.
We mixed this usually. Last year we had probably binary files. Yeah.
Okay, how to read a file, how to work with a file. So files must be opened in the beginning, and there is just a function for that, fopen, with where it just can give a path to the file, and then you can add a mode. You can say, okay, I want to read a file, I want to write to a file, or append to a file. I can specify is it a text file or a binary file. And then if fopen is done, it returns a pointer to the file, or it returns null if there's an error. We will see it in a few slides how this works in practice.
And there is a question in the chat. So is jar the binary format or just an example?
So I think this one, this is the toy jar. Yeah, this is just an example.
This is just an example.
Yeah. This is just a program we are using, or maybe you will be using next, or in a few next semesters, written in Java.
Yeah.
Yeah. And if we want to, so if we have finished working with the file, we must close it. It's a little bit like memory allocation. You can open it so you get the memory, and if you're finished you have to free it, and in this case you have to close the file again, and you just deliver the file here as an argument which you have received from the fopen. So in the meantime you can work with the file, and if you have fopen, for example, you just give a text file, and then here the second argument is the mode. There is, for example, open R. You can write just R, and this means open an existing file to read. W is creating new files to write into. This overrides existing files, so be careful when you're using that. A is append, so it's open existing file to write. And then there is special operators like this plus here, so which means opening an existing file to read and write, so you can read and write with it. And this W plus is creating a new file to read and write. This is just specification, so if you work with fopen, just look at the main page, for example, and then you can easily figure out which type of mode you need.
Right. The documentation overall is pretty good.
Yeah. So we have opened the file now, and we want to read from the file, and there are of course many functions to do that. I think the three most important or most popular one are fgets, fgetC, fgets, and fread. And this is they're doing pretty much the similar one. So fgetC reads one character from a file, so just one character from a file you hand over there. Fgets reads n-1 characters, so depending on how many characters you want to read, but it stops at EOF or \n. We will come in, I think, next slide what EOF is. And fread is, again, you read n items with the size of size, depending on the parameters you give here, from a file into a specific buffer. This does not stop at a null byte or the new line, so the end of the current line. So if you want to read one line, maybe fgets will do the trick, because it just reads until the new line or EOF. And what is this EOF? This EOF just stands for end of file, which just indicates it's the end of the file you want to read. So you could not read any further. You are done with the file, and you can check for it. In this case, the first example, you're opening a file, example.txt, and you want to read. Then at first you should also always check if it's null what you get back, because it might be that it won't work. For example, if the path is wrong, so there is no example.txt, you will get null back, and then you have to react differently, of course. And here we have a while loop. You can say then fgets, so we're reading just one character from the file, write it into this character variable, and do this until you reach the end of file, so just reading all the input you have in the file. And then you use putjar. In this case, it's just a different thing. You can also use printf, for example, and then in the end you say F close to close the file again.
There's a question in the chat which is actually pretty good. Does stdin ever have a EOF? A file, yes, because a file has at a certain point a file end. If you refer to stdin, because stdin can be something different. It can be a file, it can be like input from the keyboard. We can simulate EOF also with the keyboard. STRG, like Control plus D, I guess.
It's Control D, yeah.
Control D,
Yeah.
then you simulate the EOF actually.
Yeah.
Can you go back one slide? Actually, one thing I just realized, and that is interesting. Question to all that have been here last week as well. I think last week. Check the signature, like the function signature of fgets and fread, like the parameters. Is there anything that looks a bit strange? Because I realized something and I was not sure, and I just Googled it why this is like that. So fgets and fread. You know what I mean, probably?
Yeah, I know, yeah.
Do you know why this is like that? I just Googled it. I had no
just
clue.
realized.
Yeah.
No, I don't know why it is like that. Or I think it's just convention, but I don't know why. Is there a reason?
There's a reason, yeah.
Okay.
I checked the reason. It's yeah, interesting.
Yeah, already the right answer in the chat, I think.
Yeah.
One buffer is a char pointer and the other one is a void pointer. So.
And what I mean, yeah, that's a good point. But what and this is actually Twinny, that was not the point actually, but just like maybe a copy paste issue. But the thing is, where I realized it, int n and size tn.
Yeah.
So there's different.
This one.
Yeah,
okay.
the n. So no, like int and size t.
Yeah.
And maybe someone in the chat can give us like an idea what the difference between int and size t was. Do you have any idea what the difference was actually between size t and int? And then we present the solution why there's a difference between between n and n actually. Sorry, trivia, but I just realized that. Yeah, more precise.
So size t is just a type for another data type.
Yeah. So what we said about size t is actually, platform. And size t can always store the number of elements that can be in like an array or something like that.
Okay.
So as you mentioned, the thing is fgets is older than size t, and it was in the previous standard. There was a previous C standard, and that was before size t was introduced actually, and they don't want to change it. So that's actually the difference between both versions.
Is that also the reason why
Probably,
we have a void pointer or a char pointer?
Might be the same case actually.
Okay. All right. So any left from EOF? I don't think so.
I don't think so.
Okay, great. So always check for opening and read the character or read character by character until EOF is reached in this example. When we want to write to a file, we can use pretty similar functions. It's just put instead of read. It's fput c, which write c, so the character c to a file. It is an integer here because you can also write not only ASCII digits there. Fputs instead of freads. You have a string and you can write it to the file depending on how you read the file or how you want to write the file, if you want to append or overwrite it. So depending on how you open the file, this will be appended or it will just overwrite what you have written in the file already. And fwrite is, again, I think this is also the same reason. The newer standard, that's why you use size t here, which writes n items with size from the buffer to a file, and it returns the number of written objects, so the number of written characters, for example. All right, I think the most interesting thing when working with files is where is your current position in the file, because you can read one line and there might be a few other lines left. You don't really know where are you currently, and files allows us access to the position you're currently in. So you can use this ftell and then giving the file pointer, and you will get back the current position in the file. We will see that in, I think, next slide or in 2 slides, how this works. And you can also set rewind. So let's suppose you don't know where you are, you have lost your position. Just write rewind, then it sets the cursor to the beginning of the file, and then you can try again.
Or just you want to be sure that you're on this position, like on the beginning of the position again, then you can rewind.
So this doesn't do any harm. So if you are in the position already, nothing happens. And the very interesting, or I think the most interesting thing here is fseek, where you can change the current cursor position. So again, you can give the file an offset and an origin. So the offset is where your new cursor position should be. This could be a positive and a negative value. And the origin is your current position in the file. So you can combine this and use ftell to find your current position.
Right.
And this is then the origin, and then I can say, okay, I want to make 5 steps to the right, 5 steps to the left, and so on. And there are 3 macros defined. Macros is something like a define, I would say, And you can write there really seek cur, which just means the current position of the file. But you can also jump, for example, you can write set, which is the start of the file. You can use this as origin and say, okay, when I want to read the 3rd character in a file and I don't know where I am currently, I can use fseek, use the origin set, seek set, so I jump to the start of the file and then 3 characters in the offset, and then I can read the 4th character, for example, or seek end to jump to the end of the file. This is an example here. So I have this file, I want to read some of my heroes, and this is the start of the file. This is, let's say, my current position, and this is the end of the file. I can use ftell to print out where I currently am, and I will get 55. So this is the 55th character here. And then I can say, okay, I use fseek, giving the file, and I use -7 from my seek cur. Then I create a buffer here. I read from the buffer using fgets, and then I print it. So what could be the output here? Any guesses? Does ftell count the new line? Yeah, the new line character is 1 character. Yeah, I know it because I struggled exactly with this problem when I created it.
It's a classical thing.
So any guesses? What is the output here?
Also with characters, always think in ASCII. So there are printable and non-printable characters, and \n is a character but a non-printable character.
Yeah. So this is our current position. We are seeking -7 from our current position. Yeah, I just want to read it once.
At least there's
at least
some feedback.
Perfect. Yeah. So the output then is Saruman. So I will 1, 2, 3, 4, 5, 6, 7. So I go to the start of the current line. Of course, I could also count how many characters the current line is, and then just jumping back. Or I could also, if I want to jump back to the beginning, read where the previous new line was, and then going 1 forward, and then I'm also in the start of the next line. So there are endless possibilities here to read in a file. And it's always helpful if you're working with files, especially in assignment 3, to again try or begin with a small file, just try a little bit with fseek, what happens if I go 5 to this, -4 to in this way.
Yeah. Files are pretty straightforward actually.
Yeah. All right. I think that was it already from File.io. So we have now...
I can take over.
Yeah, Alex.
Cool. Okay.
Surprise us.
So File.io can be part of the exam actually, yeah. And this is also something that we love to give for the exam actually.
Yeah.
We're talking about linked lists, to be more specific, single or singly linked lists today. We combine the knowledge that we have about type def, struct, memory management, pointer, files, probably. So we combine everything.
Arrays.
And I have a cool example. So actually, let's have a technical look at a playlist. It's December. It's this time of the year where everyone gets the Spotify and Deezer playlist from 2023. And actually this motivated me for my following example. I received my top songs last year. Please don't judge me. Some songs I don't understand why they're actually within the list, but they are. So let's have a technical perspective on the playlist. Actually, let's consider one concrete song and let's decompose. Let's have a look what a song actually is. So what attributes does a song actually has? I mean, we have an artist, we have a title, we have a length. Album category as well, sure, but in that case, we just go with these 3 elements because otherwise we have to do a lot of programming later on. We don't want to do that actually. Cool. How could this look in C code actually? And I think all of us agree that if we're creating a struct, which we call song, like here, we have these 3 arguments or these 3 attributes, artist, title, length. And they are our so-called members. And we know this from last week actually, because we talked a lot about structs there already. So we have 3 members. To have an easier example, I just assume that they cannot be longer than 50 characters, because otherwise I would have to allocate the memory for the artists and the title, and this might be a bit annoying. Okay. So actually a playlist is a list of songs. And in order to have a list, we have something that we see here on the left, so with the arrows, we have to always go somehow to the next element. And this is where we actually have a list. And so we add one additional thing to our list or to our struct. We add the next song actually. And this would look like that. So actually we have artist, title, length, and then we link, and this is why it's called linked list, to the next element, to the next song. Actually, this is the idea of what a linked list is. We have some data and we have a reference to the next element. How would this look as code? For code, things that we already know, 3 members that are pretty straightforward, and a 4th member, which is a reference to the next struct. And I think this is clear because the next element has to be a struct, because it's a song, and the song is always a struct. And since we want to have a reference to the next one, we have to use a pointer here. So we have a pointer to the next element. I stop here for a second. Is this somehow unclear? Or is this clear for everyone? Yeah, homework 2 flashbacks, right? Was another motivation for me to actually use this here again. And also we do the programming today about that. So any questions so far? So we combine things. We just have type defs and structs now.
What does short mean?
What does short mean? Good question, actually. Maybe someone in the chat could answer that. What is short? Any ideas? Right. It's an int with just 2 bytes, a small int, half of an int. Yeah, right. Felix, we have our int with our long and we have our short. And I assume that there might not be songs that are like super long. Yeah. So that's it actually.
I have a question here. Do I need this star next song? So would it be possible to write struct song next song? It's not a pointer.
That's a good question. Actually, no. Because we get in trouble, and the compiler will also tell us that we get in trouble, since then we have like this kind of a recursion, because actually the compiler doesn't know how much space, how much memory there should be allocated, and so that's the reason why we can't just use a pointer here, because the compiler knows this is 8-byte.
Yeah.
And this is the reason why we just can't use it here. So you can do it actually, just take this code, try it without the pointer, you will see, you will get in trouble.
Won't work, yeah.
Good question, actually. Could be a trick question if I don't know that. Okay, so let's talk about some list operations. So when we think about the playlists, we want to add songs, we want to remove songs, we want to print songs, we want to modify songs, whatever. I will talk about the most basic operations, because when you understand these, you understand every operation on a list. Let's assume the following thing. We're having a list, and the list always has a next element, and if there is no next element, we point to a null element. Like the very last element is always null. This is quite easy then.
Would the size of the struct be 112? So we go back, it's 50 times 50, then 2, it's 102, and then 8.
Could be some optimization as well to get...
Might be 112, yeah.
And shuffle. Yeah, I mean, shuffle could be possible, could be a function actually. Shuffle to reorder the list. Okay, first thing we want to do, we want to iterate over the list. Iteration means always we go from one element to the next element. The idea is we start at the very first element, so we have to keep track about the very first element, because if we forget what the first element is, then we cannot go through the list. Yeah. So we always have to store the very first element, and the cool thing is we know the first element and we know that the last element is always null. So what can we do? We can start at the first element, which we call current, and then we say our current element is current next. So we move actually from this element to this element, and this is now our current element. And again, since the condition is not reached, because our condition could be as soon as current is null with the very last element, and then we stop our loop, for example. And so we did again, current is current next, and then we're here, and then our condition breaks because this is the very last element. Pretty easy. We have a iterate function, and this iterate function takes the very first element. So playlist is a reference to this very first element. And then we actually say, okay, element equals playlist. I will come to this in a minute why I do this. And then we go through the list until element not equals null, and then we at the end of the list. What happens if you create a loop by setting the next element to a previous element of the list? Then you have a graph. What happens if you create a loop by setting the next element to a previous element of the list?
We will have a loop then. Or it might be that So you can also iterate. It depends. So if you have just a single linked list, like we are talking about,
then we cannot go back.
We cannot go back because we do not store the previous one.
Right.
We only can remember, or we have only the pointer to the next element.
Yeah.
But there are also double linked lists. We have, which also have a pointer to the last element. So pointer to the next element and to the last element. Then we could go back also.
Right. Yeah, we can also add something to the list. For example, we want to add at the very end another song. Then pretty easy actually. We create the new element, and the new element is just a new struct, and we don't have. For now, we don't. We haven't added this, and what we now have to do is actually to find the last element, which is this one. Which means I will also start again at the very beginning, because I just know where the beginning is. If I have a double linked list, I could also store like the very first and the very last element. Could do this. I could just do this here as well, but question is if this makes sense. So I'm starting with the very first element, and I'll go to that one, and the condition might be that we are checking if the next element is null, and this is the case here. And then I just say, all right, this is our last element. Let's add here this element by saying the next element of the current element is this element. And this is how we can actually add a new element. Any questions regarding that?
It was just a statement that before he means that we create like a ring. So we connect the last one not to null, but connect the last one to the first one. Then of course you have an endless loop because you do not reach null at any point.
Does not make that much sense probably. So if we want to remove something, let's do the easiest case. Let's remove the second song, HR song. We delete this. What do we need? We need two things now. First, we have the current one, and we also need to store the previous one. Why do we need this? Because if we don't have the previous one and we want to delete that one, then we cannot delete this element. Because when we delete this element, we have to say that after the Bob Dylan song, the Dubliners song will be the next one. And if we are just here on this element, we cannot access the previous element. And this is why I have two different pointers, one to the previous element, one to the current element. And then I can say if the condition of the current element matches the remove condition, which could be the ID or the name or whatever. If this matches, then I say, okay, the previous element points to the next element, for example. By doing that, for example, and obviously, please do not forget to free. And then we have removed it actually. And that's almost everything related to remove. With another edge case, if we want to remove the very first element, that one, we have to consider something different, because if we remove this one, we have the second element, and the second element gets to be the first element. So what we have to do in that case is say this is the head, like the first element. So we have to say this gets the head, this is like the previous element, and then we have to delete that one and say this is the new starting element actually. And then this should work as well. All right, this is the theory. And now I want to do some coding. Actually, to make those things a bit clearer, you don't have to write the code. We will provide you with the source code afterwards. So no need to code with us now. Just focus on what we're telling you. Okay, let's start. What would you say? What would be the first element? Maybe just type in the chat. How should we start actually this example? So how would you start now? We want to like program the add function and maybe the remove function what should we destruct? Yeah, that's a good point actually. So we say type def because this makes things easier. Struct song, and then we have different members. We have the artist. We have the song title. We have the length. And what we also have is the next element. So struct song next song. And as we said, this has to be a pointer. And then we say song. Because this is the tag for here, and this is actually like that for the type def, and this is how we call it now within our program, song. Everything clear?
Yep.
Right. Okay. Now we want to add a new song to a playlist. So maybe let's start by saying we have a new playlist actually. And this playlist is just null from now on. And now we want to have an add function, and this add function should take the playlist. We call it add song, and it takes a playlist, so which is actually the start, and then it takes an artist, a title, and the length. What did we have? Bruce Springsteen with, forgot how long it was. I don't know. Let's write something. Okay. What we could do is we save this in the playlist then. All right. Everything clear so far?
Yeah.
Okay.
Just short comments, but I can answer them.
Perfect. Okay. Now we want to write an add song function. And for the add song function, we need some things. First of all, a function description, like a prototype. We take the playlist, which is song playlist. We said we have a first element, artist, we have a title and a length. Okay. How do we add a new element now? We want to do this on the heap, right?
Yeah.
Cool. So
I think we never done this.
we never done this, but
Creating a struct on the heap.
how do I get a struct on the heap? What would be your idea now? Any ideas? We want to call the heap now, like this magical thing that has an infinite amount of memory for us. How do we actually get something on the heap now?
So today we already talked about how the size of a song, the size of a struct.
Malloc, size of song, wow.
Yeah.
I'm impressed. Size of song. Okay. We don't have Copilot, this is good. What should we do now? Like it's a trick question, kind of like a style guide reading question. What should we do now?
By the way, I think it's good practice, and you should also do it in the assignment, just to write a function which creates the struct. Doing everything together, creating the members, and doing all the checks, and then return the full working song in this case, so the full working element.
Yeah. If something fails, we say return null. Okay, so we have the case that there was an issue with the allocation, but now we got the memory, the space on the memory on the heap, and so we have a new element on the heap now, which has enough space for us to actually write these things in. Okay, which means we can say new song, artist. We say new song and have this arrow because this is a pointer.
Yep.
If this would not be a pointer, we could have the dot, the period. We could also say with that one, but we will take the arrow operator. And then we say, I don't know what I'm doing, artist, right? Right?
Yeah, that looks good.
That looks good.
I can see any problems.
I don't see any as well. All right, should work now. Hopefully.
Yeah, so we're taking the artist and write it into the artist. We're taking the title, write it into the title. And taking the length and write it into the length.
Yeah.
Looks good.
Looks good. And is there anything? Red line says something different. What does the red line say? Expression must be a modifiable value, L value. Don't have any idea what this means. And it is from the chat. What could be wrong?
What is artist? What is of a data type? Is it a pointer or is it an array?
It's an array.
Okay.
Dereference the pointer.
Reference the pointer would not help because we already dereferenced the new song pointer using this array. Arrow.
Ha!
Now I can see it, yeah.
Perfect. Yeah. We did a very common error. We cannot do this since we're having like two strings. And as you know, doing this would mean we assign like an address to an address. We don't do this. So what we actually do, we make a string copy or
So like this, we just assign the pointer, so just the variable, the address, into this array.
Right.
This won't work. So we use str copy in this case.
Maybe a question in the chat. What is the n copy? Yeah, there's a difference to the str copy.
The amount of elements to copy. Yeah, exactly.
Okay, do we have to do this here as well with the length? Any thoughts on that?
There's no red line.
There's no red line. I mean, this is a good answer actually.
So what is length again? So
the song length.
The member is
so short.
So short.
No, because it's just a short.
Yeah.
Perfect. Yeah. We promised that we return a new song. Okay, let's do this.
Yep.
Return new song. Should be good, right? Any concerns in the chat? Are you fine with that? Can you please explain why we don't have to copy the length? Oh yeah, sure. I'd love to. The problem here is that we want to copy the values of a string. And if we do it like this with the assignment operator, we would copy the address. And we cannot do this actually. So this does not work. And since this is a short, or if you prefer, we can have it as int. Maybe you're more familiar also with int. Do this, of course. We just copy a value. Like we copy 421. And this would be the same if I would say something like, let's say this is 421 and then we say length 2 is length. So this would be actually the pendant.
So this works.
This works.
Yeah.
Trust me. Okay. We should return the playlist and still have to set the pointer. Yeah, good point. Because what we did now is we just return the last song. So what we could do, for example, is say new song. Next song equals playlist. That would do the job. All right. What I really love about linked lists, and please treat this as a good approach, print it now.
Yeah.
Printing a playlist or printing a list is always good to actually see if the things that you're doing are not completely off. So let's say we want to have a function, print playlist or playlist, yeah. It's always a bit confusing if you have another keyboard. So
maybe everybody should bring their own keyboard.
Don't think so. Does this make, this does not make any sense?
No.
This makes sense now. So I will call a new function that we're about to create, a print playlist function, and this function void because it's printing something. We don't expect to do something different than printing, and say print playlists. And now here we arrive with playlist actually. And I mean, we did this already in the slides, so pretty straightforward. We just say while our playlist is not null, then we just print it by saying, okay, we have the artists, we have the song, and then we have like the duration, and then we're good. And then just say playlist, artist, playlist, title, and playlist length. Okay, if you would run this would work, but work too long actually, because what we also have to do, of course, is to say we want to set this to the next element. So we say playlist equals playlist next song.
Great. I think we should try it now.
We should try it now. I always go the hardcore way.
Yeah.
How's it called? ESP?
ESP, yeah.
Let's call it playlist. Okay.
No new line enter file. A common error. That's why you included the
right. And I think he's also complaining because we have to include string library as well. Nice. Okay. Let's see.
Yeah.
Nice. That looks good. I'm a huge fan of \n. But besides that, I think we're good. Yeah.
Okay.
Cool. So
should we add a second song?
We add, yeah. Let's do this.
The good thing is it's now so easy to add songs. Just call the function. Everything is done inside.
Yeah. We have to compile again, obviously.
Yeah. That's
cool.
it.
Cool.
I have a question.
Yeah.
Because I don't know if it's on purpose or not, but where do we add the song?
At the beginning.
Yeah.
At the beginning, and this happens actually here. That was on purpose to make
Okay.
it a bit easier. Yeah.
Okay.
So actually, I start with the new song in the playlist.
So it's also very easy, or even easier possible, to add elements in the beginning, because we do not need to iterate over all elements inside.
Yeah.
And just take the beginnings, the head of the link as next song.
And that's the thing. If I want to edit at the end, I have to go to the end.
Yeah.
I mean, we know how we do this actually.
It's like this.
It's like this, but to keep it easier, I decided to do it like that.
All right. I think we have
13 more minutes.
30 more minutes.
Should we add something in addition? I mean, we can delete something.
That was a good question.
Yeah. Should we use a temporary pointer?
In this case here.
In this case here.
Oh, that's a very good question.
Yeah.
So the thing is, in general, yes, you should do this. In this particular case, what you should know is that when we call this function print playlist, we copy the pointer to the playlist. So in the main function, when we call it, the pointer does not change. So we copy the values, we copy the address inside the new function, and then we can use it. Of course, we lose the pointer inside the function. We lose the head of the function, of the head. We lose the head of the linked list. But in this case, we do not need it anymore there. But maybe if we want to extend it in some way, it would be a better idea to write it like this. And then we always have the head of the playlist.
Good practice.
Yeah.
And in some cases, this might help you a bit, because with pointer and these kind of things, you might lose something if you give the address. Yeah,
I would recommend.
Yeah, it makes sense. It makes absolute sense. Yeah, sure. Good idea. Good point. Yeah.
What do we have left?
I mean, we could use, or we could do some delete function. By the way, I have a complete code with, I don't know, 200 lines of code, something like that, with deleting, cleaning also up, because when we add at the end, we want to go through the list again, delete and free everything. So I will provide it with this code. I tried to comment it, really helpful, so you can always watch this code. But I think since I have 2 slides or 3 slides left, maybe go to the slides.
Okay, yeah.
If you have any questions to the code that I provided you, it's just a example. I crafted it on the train to Graz, so maybe there might be some optimizations that would be better. Please feel free to ask questions regarding that, but so that you see like a larger example of something. Because what I wanted to show you actually are some 1 or 2 other data types as well, which might be very interesting. Double linked list, actually.
Yeah.
We talked about this earlier, so it makes sense in one direction to go through the list, but sometimes it might also be good to go back again, because then we don't have to deal with this thing to always like save the previous element things. And so this might be a good idea actually to have to have like the previous and the next element as well. Yeah, so this makes going through the list easier, because then you go back and forth. There is some overhead, there is obviously also some complexity. I was just thinking of some use cases that I could suggest you, for example, for navigation, like in a browser or something. Undo, redo could also make sense. Or if you have like some history where you want to go to the past, go back to the future, like future means the present actually in that case. That would make sense. Yeah, this is actually the double linked list. If there are any questions, please ask. And the second thing is the tree, or the binary tree. We have seen a tree already.
Yep.
Where have we seen trees again? Where have we seen trees actually? Any ideas? Where was a tree?
So in general, the term tree is interesting because it's growing downwards.
Yeah.
So
I mean,
like
you can...
Like the roots.
Yeah.
Or you can just...
Yeah. In nature, I was also about to make like Schenkelklopfer and say Stadtpark, haha. You're right, but we've seen a tree earlier this day already. You know what I mean?
Yeah.
Yeah, yeah.
I know.
I was just concerned that my question was stupid. I mean, it's actually a stupid question.
Doesn't mean it was not stupid.
Right.
In the recap, actually.
In the recap.
Yeah, so we also talked about it last week when we had this mom and dad connection.
Right. So this was actually a tree already, like a family tree.
Yeah.
When I took ESP, our example was a family tree, actually. Family tree, yeah, right. Cool thing with the tree, it's very similar actually to the double linked list.
Yep.
Because we have a previous, we have a next, and here we have a left, we have a right. The hierarchy gets a bit different. So trees are like a super cool data. I really love trees. And we decided earlier that we will do something with trees probably next week as well.
Yep.
Trees are really cool and they give you some really cool possibilities. And I think trees are a good example that shows if you have a good data structure, you don't have to program that much actually. A binary tree ideally could also be sorted. For example, you start here with like the letter M. So if it is like a tree with, we want to search something, and then you have here everything that comes before M, here everything after M, and then you know, okay, this is everything that starts from N, this is everything before that. So this makes searching actually easier because in a linked list you have to go linearly through the list. So cool thing, we have a root element, which is like the very first element, the starting point. We have to keep track of the root. And then we have children, a left and a right children, and then we can go through it. So for searching, for sorting, it's really cool. I mean, it adds a certain level of complexity, and there can also be the situation that we don't want to have, that we have an unbalanced tree, which means if we always add like here, like on the very right element, what happens is we get an unbalanced tree, actually a linked list, because this flattens the structure of a tree down to a linked list. Usage are decision trees, which you will hear later in artificial intelligence subjects. Cool thing to actually make decisions based on some input. Compression, maybe you heard about the Huffman compression actually, or also in file systems, of course, like in the file system where we have like a root directory and then we're going down in the file system.
The cool thing again is with these data structures, you can visualize it so easy, you can draw it very easily, and then it's so much easier for me to understand how or what happens under the hood. So
right.
Yeah, I don't know how many trees I created with pen and paper. I think there are 100 maybe in my study. So
you will fall in love with trees. So trees are really cool data structure. Yeah. All right. Today we will stop a bit earlier because I have to go to the Alte Technik within 20 minutes because today we have like an event there. So we will first time I think stop a bit earlier.
We used this time before, so it's okay to
we used this time like all the 7 lectures before that. So thanks for being here. We will upload this, I think, tomorrow because we have also Christmas party with all the tutors today. So we might don't do this today, but latest point is tomorrow. And if you have any questions to linked lists, to trees, to whatever, next week, good chance to ask them. Or as always, Discord, feel free to ask. I would love to explain this.
I just want to mention that we forgot something very, very important because we used malloc here.
Yeah, free.
and we never called free.
But I think I said that we should
We should do
do
it.
this.
Yes.
Yeah.
So this would be really the next step where we
Yeah.
continue.
And in the code that I will provide you, we'll see actually how to free the entire playlist, how to free when you delete, these kind of things. As I said, I commented everything, so please have a look at that.
Great.
Cool. Then I think we're good for today. So thanks for being here. We will see each other next week to the very, 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 very last
Yeah.
ESP lecture
And a special Christmas
and a
edition.
special Christmas edition. Yeah. So see you next week
Yeah.
and have a great weekend actually already.
Bye.
Bye.